this is surgical medic on your screen, and we'll be going into physics. We'll be going into the study of physics. The very first topic in the syllabus: measurements and units. Measurements and what? Units. So, alright, we'll be looking at a number of things under measurement and units. So, under measurements and units, we'll be looking at our fundamental, and what's derived quantities. Then after that, we now look and the units too, and the units quantity and units. Then we'll now go into the measurements of these physical quantities. So alright, now measurements and units. When we are talking about measurements in physics, they're actually talking about your the measurement of or let's call it estimation, the estimation of the magnitude of a physical quantity, so the magnitude of a physical quantity. So if you are trying to estimate the magnitude here is actually telling you about the size. So if you are trying to estimate the size of a particular quantity, of a physical quantity, you're actually talking about measurements. Now, what do they mean by physical quantity? This physical quantity that you are trying to tell us about is for example, now you can see okay, let's say something you can see is a physical quantity. And for example, now maybe you have a cup, all right? You have a cup at home. That cup is a physical quantity. Let's use another example. You yourself, you are a physical quantity. But when it comes to physics, we are actually going to describe the properties. We are not going to be looking at you in physics. Okay, you are saying that okay, you are a physical quantity, but it is not you that we will be looking at in physics. We would rather look at that properties that actually define you. Are you with me? Those properties that define you. For example, this is you. So now, what are in physics? We will not say that this is a physical quantity actually, but there are properties we would say about this, and those properties are what is referred to as the physical quantity. Now, what are those properties? Yeah, the properties we can see in this particular person here is mass. I can also see his length now. From here to here, show you get his length. Yeah. So, but when this body begin to walk a distance, that's when we now say okay, we can also see the time, and we can see what the distance, the centimeter or meter. So that means another property here is what? Time. So these are things we use in physics when they are talking about physical quantities. And the basic unit physical quantity that we have now, your MLT, medical laboratory technology, MLT, which is your mass, your length, and time. You get, so that's physical. So if you are trying to now get the magnitude of these quantities, we are trying to do what? We are trying to measure. We are trying to measure. So the estimate of the magnitude of this physical quantity is what we now refers to as the measurement. Now the unit is something like maybe the standard and accepted let's call it letters, or let's say alphabet that we use to represent these quantities. For example, mass. Now the unit of mass is what? kilogram. This is the standard alphabet, the standard letters K and G that we would use. So this is what is refers to as the unit. Unit. We call it SI unit. So that of length would be what? Meter. While that of your T, which is time, would be what? Seconds. So that's simply the unit. While measurement is now the estimation of the magnitude of a physical quantity. So that's that about measurement and units. Now let's go to fundamental and derived quantities. So yeah, when they talk about fundamental quantities, they're actually talking about those quantities that we use to obtain our derived quantities. So if you are talking about, okay, what are those quantities that we use in deriving or in obtaining our derived quantity, you will refer us back to fundamental. Are you with me? So it's from our fundamental that we are actually going to get our derived. Are you with me? So now that's fundamental quantities. Now derived quantities. Derived quantities are those quantities that are gotten from fundamental. So it's just like the two of them helping themselves. Yeah, like fundamental would help derived. Why derived would help what? Fundamental. So fundamental here we would use it to like obtain derived quantity. Why derived quantity is actually gotten from what? Fundamental quantities. From fundamental what? Quantities. So now let's now check the examples of our fundamental quantities. All right, let's check. So let's check examples under fundamental quantities. So we have our what? Our fundamental quantities. Then the units. The units. So alright, now. So under fundamental quantities now, the mnemonic I use to code it into my memory in such a way that I will never forget again is Ella. Ella is in MLT department. Ella is in MLT department. Now, that department, we know the departments now, medical laboratory technology, alright? And that medical laboratory technology is what I used earlier, that I called our basic units, our basic what? Fundamental quantities, physical quantities. So MLT, you get now. So that's the course Ella is studying. So the course Ella is studying, ML of T, and as well as Ella, ELA. Are you with me? Ella. So right now, when I say okay, my M here, you know that my M is just my mass, my L is my length, my T is my temperature, my E here is my electric what? Current. Are you with me? Electric current. My N would be luminous intensity, while my A would be amount of what? Substance. Are you with me? Now let's now check the unit. The what? The unit. Let's now check the what? The unit. So mass there would be measured in what? Your kilogram. Yeah, your length there would be measured in what? This one is for kilogram. So your length here will be measured in what? Your meter. Are you with me? Your temperature here will be measured in what? In what? Kelvin. Current, ampere. Then luminous intensity is, that one is in candela. Then amount of substance in what? In mole. Are you with me? So that's that. Let me write the mole well. mole. So that's our examples on the fundamental quantities. So these are the quantities that we would use to do what? To obtain many more quantities. And that many more quantities is termed derived quantities in physics. So basically, these are our fundamental quantities. Are you with me? So I think that's that under fundamental. Let's just check for derived quantities now. Let's check for derived quantities now. So yeah, derived quantities, they're actually much. Actually, they are much because they were gotten from your fundamental quantities. So they are very much. But I would like ensure I explain well in such a way that you'll be able to go and advance it by yourself. You'll be able to go and so that you'll be able to recognize your fundamental from derived. So let's look at this derived, just like the name implies. Let's derive from fundamental. For example, now the very first derived quantity we should look at is our area. Wait, let's write derived quantities. Derived quantities. Now, so yeah, our area, right? Area. So area is actually coming from the derivation of length and breadth. So length is your fundamental quantity here, and breadth also is another fundamental quantity. So the multiplication of these two, the multiplication of these two is the one that actually brought about the area, that brought about the derived quantity called area. So yes, we have our what? Length times breadth, which our unit here too is derived. And how is the unit also derived? It's derived from your length in what? Meter. Your breadth too is what? Meter. So meter times meter is meter square. So why your length times breadth is length times breadth too. Sure you get. So that means your area, the unit for your area is what? Meter square. Are you with me? So okay, now if we are not trying to if we are trying to add height here, that okay, length times breadth times our height, that means that it's not area again. Are you with me? It's not area again. That means you are talking about your volume. Are you with me? You are talking about your what? Your volume. And this your volume here is actually the unit too would not be meter square again. It will now be meter raised per 3, because the meter is now 3, because height also is measured in meter. So meter multiplied by meter for the unit. How we are deriving this, how we are actually going to derive our units. So the height what? In meter. So the three of them is now the one that now give us our meter cube, meaning that the unit of volume is what? Meter cube. Very very what? Very simple. So this is the basic concept behind you deriving your stuffs. And where are you deriving them from? You are deriving them from fundamental. So that fundamental is either you maybe multiply them, fundamental quantities, when you are multiplying fundamental quantities together, or you are even doing the two, like you are multiplying as well as dividing. Yeah, so let's check that type. Very fast. That type of one of which one save? Let's use our force. That one is kind of complex. Let us use force for now. Yeah, let's use force. So force now. Our force is, what's the formula of force? The formula of force is simply your mass times acceleration. Your mass multiplied by acceleration. So now, how are we going to now know that it's coming from fundamental? Alright, so the mass here, actually, that this is our basic physical quantity now. From here, I told you about MLT now. So your M. So now let's now resolve the A. Let's resolve the A and try to prove that it's actually coming from fundamental quantity. So our acceleration here is now what? Your velocity over time. You know now the rate of change of velocity with time is acceleration, right? So now your velocity over time is acceleration. Now you know this velocity also, is it part of our physical quantity? No, it's actually derived also. How is it derived? That's your distance. Your velocity is what? Distance over time. Mean that this is actually, all this is actually resolved into your velocity is distance over time, right? Distance over time, then divided by the time that was here before. So meaning that this is your velocity now. You get, your velocity is okay. Let's call, because the standard, the correct and professional way of defining velocity is that it's the rate of change of displacement, not distance, because speed is distance over time. But here now we're able to like denote that d, which is distance, is actually similar to, or like, how will we say it now, like the standard way of writing a d is L. So it is expressed as what? Our L. Our L. So your D here is L. So your D will be written as L. So when you get to dimensional analysis, that's the next after this topic, dimensional analysis. That's where you'll be using all these things. Where your D will become L. You get, where your D will become L, your L will become M. Yeah, and all those stops. Your T will still become T, will still be T. So now the D here is L. From what I've explained, is L, right? So that means that would be our LT if 2T is actually coming up like that, to be -2. Now 1 2 is coming up -2. So that's, let us go into dimension. We'll take care of that in the next video. We'll take care of that in the next video. So here we see that our A is from L and T, right? L and T. So that's how we have our M multiplied by our L of T raised per -2. Don't worry, when we get to our MLT -2, can you see how this was actually, how our force was derived from our fundamental quantity? Are you with me? Our fundamental quantity. Are you with me? So that's for fundamental. That's for derived quantities. I think we should look at now the unit too. The unit is actually going to be from, let's check, let's derive it again. So if we are deriving also, now this fundamental quantity here is measured in kilogram, right? That will be multiplied by your length. Your length is what? Meter, right? Then your time is what? Seconds. Why it's actually carrying -2, and you obtain your simple unit there. So that means your force, this is the unit of your force now. And if you want to go directly without passing through the this thing, you just go to your formula, the one we use to identify, to check if it's actually coming from fundamental. You now say, okay, mass is kilogram, acceleration is meter per second square, then you add meter per second square, and that's all. Very easy. Very what? Very easy. So we should look at more derived quantities. We have other derived quantities. We have torque. We have our torque. We have our energy. We have our energy. We have our power. We have our power. We have our speed. So all these things, we have our acceleration and many more. Electric field intensity, electric potential, gravitational potential, and all of that. So now let's move because of our time. Or should we do one more derived quantities? Maybe we should do for that of let's do for that of acceleration. We've done that here. Okay, let's do one more. So for speed, let's do for speed. Speed is actually gotten from the division of two fundamental quantity. All right, two fundamental quantity. Now what is speed? Speed is the rate of change of what? Of distance with time. All right, now, and I told you that the under dimensional analysis is expressed in terms of L. So you're actually substituting the d there. Anywhere you see d, anywhere you see distance, you'll be using length for it. Are you with me? You'll be using length for it. So yeah, d here will become L. Are you with me? D will become L. So, and if d is becoming L, that means we are having our LT. So resolving this now using the way we resolve. So LT, L, then let's call this capital T sharp. That's how it will be written professionally. So if T is coming up, it will become -1. Please take notes so that in the next video you should understand it much more better. So LT raised to power what? -1. So, and you know that this LT is actually coming from where now? From our physical, our basic, our fundamental what? Fundamental physical quantity. Are you with me? So that's how we actually derive our speed. So you can, I was able to prove that this speed is actually a derived quantity. So, and then we know our units now. So this one is in meter, time is in what? Seconds, and it's carrying raised by -1. So meter per seconds, not square, meter per seconds. You get, that's the scope. That's the scope. So many more examples. You should check your textbook, check your PDF. If you don't have a PDF, you can message me. I'll send the PDF to you. So you will see many more examples: acceleration, velocity, electric field intensity. You know, many more examples. You get your ohms. Many more examples. So let's check yeah, measurements of our physical quantities. So I told you about physical quantities earlier now, that they are simply your mass, length, your time. You know, in physics, your time, we have those that are fundamental, we have those that are derivable. They are talking about physical quantities and they are not specifying, so you can actually mention, you can tell them plenty this thing, that okay, mass, I have my length, I have my time, my volume, you get, and weight. Sure you get. So yeah, let's check for the measurement of physical quantities. And the physical quantities will be looking at the measurement of what? Of our mass. Then after that, we check for that of weight. After that, we check for that of what? Time. Are you with me? Time. So yeah, let's check for the three. Measurement of the three of them. Alright, so let's go into that of mass first. Mass first. Mass. Alright, so mass. What is mass? Mass. What do you understand by mass? Mass is actually the quantity of stuff, or let's say quantity of matter contained in a body. Alright, before we establish this fact, let's understand what matter is. You know your matter now from your chemistry now. Matter is anything that has what? Mass and occupies space. So anything at all that has mass and occupies space. So your book, so far it's actually occupying space, it is matter. So far it's having mass, so far it's heavy, so far it's having, like, so far it's sitting on that table, so far that your book is occupying space, it's a matter. Anything that have mass and occupy what? Space. Yes. You yourself, you are a matter. You are a matter. You are a matter to me, because you are what? Occupying space, and you even have mass. Can you imagine? So anything that have mass and occupying space is your matter. Now what's now this mass? Mass is now the quantity of what? Of stuff. I like that textbook that says stuff, because it really stuffs. because in your body we have a lot of stuffs. You have your digestive system, you have your skeletal system, you have a lot. In that same body you have your nervous system, your neurons, everything. So the quantity of all these stuffs in your body, this is the mass. Now how are we now going to measure the mass of an object? Now that you understand what mass is, you should be able to tell us what you use to measure mass. Now you cannot just say mass is the quantity of stuff in the body, and you cannot tell us what you use to measure mass. Now what are we going to use to measure mass? Is it our spring balance or our beam balance? You need to think of it. If you see this kind of question, what would be your answer? Are you going to go for spring balance or you go for your beam balance? Alright, so here you will not go, if you choose spring balance, you are very very wrong. You are very very wrong, because under mass we use beam balance for mass. We use beam balance to measure the mass of an object or body. Are you with me? So, and how do I know? Somebody should ask me, how do this guy know? Okay, this is how I know. I'll tell you. I use my course as a mnemonic to code it into my memory. What's that course? Yeah, this is it here. MBBS. Alright. So that means my mass. Are you with me? My mass. I'll be using my beam balance to what? To measure it. So use beam balance to measure the mass of an object or what? Or body. Are you with me? An object or body. So that's it. Code it into your memory. MBBS. That means I will use beam balance to measure mass. MBB. Are you with me? That's mass. Now after that, we should know that this is actually working on principle of moment. Your principle of moment. Please don't forget, it's working on the principle of what? Moment. Principle of what? Of moment. So alright, that's that about that. Then we should be able to explain if mass changes from one place to another. Does it vary? Does it vary from one place to another? This is actually asking. This thing is actually saying that if you go to Abuja from here, okay, you are currently in Lagos, right? So, and you want to travel to Abuja. So, is it that your mass will change when you go to Abuja, or when you get to Abuja? No, your mass will not change. Your mass will remain the same. So that means mass does not vary from place to place. Mass does not vary from what? From place to place. The same mass that you are having where you are, in that Abuja where you are, is the same mass you would have when you get to Lagos. Are you with me? So mass does not vary from place to place. I think that's that under mass. So we've been able to establish the fact that mass is the quantity of what matter contained in the body. The instruments we use to measure the mass of a body is what? Your beam balance, and it's working on the principle of moment, and that it what does not vary from place to place. The mass of a particular body is constant. Are you with me? And then don't forget, before we move on, that mass would always be measured in kilogram. So in any question in physics, that you want to solve any question and they give you your mass in grams, you should do what? You should convert to what? To your kilogram. And how would you convert from gram to kilogram? From gram to kilogram is simply divided by what? 1000. So your G divided by 1000 is your kilogram. Are you with me? Are you with me? So, alright, that's that about that. So let's go to weight. Weight. Now, what is weight? let's look at weight. What is weight? Now, the weight is the like earth gravitational pull on your body, like the earth, like the earth gravitational pull on your body. So this pull would actually draw that object or body towards the center of the earth. Are you with me? Are you with me? And this thing is actually acting what? Downward. It's actually acting what? Downward. Where you have your W equals to mg. So for a particular what object, let's say this is an object now. So the force that is acting downward is always your W, and your W is what? M of what of G. Are you with me? So weight is the earth what? Gravitational pull, the earth force, on your body. Are you with me? So that weight too, if you want to know that, okay, what's the SI unit of weight now? It's simply Newton. Why? Because it's a force. And now force that is pulling your body. So just know that the unit of weight is what? Your Newton. Are you with me? Are you with me? Your Newton. So alright, because weight is a force now. Yeah. So what instrument are we going to use to now measure the weight? Is it beam balance? Also, no. We would not use beam balance because beam balance for my MBBS will be used to measure mass. But yeah, weight we use this thing that we used to open our PDF, that WPS. That's WPS. I'll use my WPS to code it into my memory in such a way that I'll never forget again. So WPS. I use it to open my PDFs. So W here is the weight, S here is the spring what? Spring balance. That means I will use my spring balance to measure the weight of an object or what? Or body. Of an object or what? Or body. So good one. I think you understood this and you cannot. Okay, if they wake you up now, okay, you are sleeping, now wake you up all of a sudden, tell me what we use to measure mass. You shout beam balance. Or you to measure weight. No, spring balance. Are you with me? Now, good. We said mass actually does not vary from place to place. Let's check for weight also. Would weight vary from place to place? I'm trying to give you expo already on how JAMB set questions for you. Sure you get. So now, does weight vary from place to place? Yes now. It varies though. Because for example now the gravity on the earth is different from the gravity on the moon. Look at the gravity of the earth. Let me check. The gravity on the earth is actually 9.8. Are you with me? But the one on the moon is 1.6 meter per second. Are you with me? So since the one on the moon is meter per second, it's actually going to affect the mass of any particular object placed in it. For example, let me explain. On the earth, we are still on that way too. Please don't forget we are still on that way too. So let's establish that fact. Now, on the earth, let's check on the earth and then the moon. On the moon, what's the gravity on the moon? 1.6 meter per second square. Then the one on the earth is 9.8 now, the one that we use. But in JAMB, please always use 10. So this one is for 100 level. 9.8 or advanced studies sha. That's why you're using your 9.8. But if JAMB give you in your question, that's where you can now use it. Are you with me? So alright, now this earth is a particular place. Place 1. Are you with me? Why moon is another place? Place what? Place 2. Alright. Now the mass that of the body, because there is a particular person which is Adebola. Adebola is on earth and is planning to travel to the moon tomorrow. Are you with me? On the earth, his mass is actually, let's use 40 kilogram, or let's use 10 kilogram. 10 kilogram. So for the mass here, the mass of Ade, are you with me? Mass of Ade is on earth, alright. Ade is on earth. So and it's traveling to the moon tomorrow. And mass cannot change now. His mass would always remain the same because mass does not change from place to place. So Ade is having 10 kilogram mass. So now let's now check the weight of Ade on the earth. How are we going to check for the weight of Ade on the earth? The weight of Ade on the earth would simply be from my weight now, normal mg now, W, the weight of Ade is the mass of Ade. The mass of Ade is 10, while the weight of Ade is 9.8. Now when Ade travel to the moon, Ade weight was now weight m of g. So now the mass on the moon does not change, your 10 kilogram, then multiply by your gravity on the moon, it's now 1.6. Now check, if you press this on your calculator, what's your answer in Newton, right? In Newton. Then what's your answer for this one in Newton? So that the what's it called, the weight on the earth is actually more than the weight on the moon. So you can see that it varies. You can see that it's not the same. So the weight of a particular object or body varies from what? From place to what? To place. From what? Place to place. So are you with me? Are you with me? So if I should now ask you, gravity also, does gravity vary from place to place? The answer is what? Is it yes or no? Yes. Now it varies because, for example, on Earth it's 9.8. When you now get to the moon, it was now 1.6 as well. So you can see that it's actually varying. Not like the mass. If, for example, the mass of your body now, the mass that is contained in your body will always remain the same. But everywhere you go to, if you go to America, that same mass that you have in your body here in Nigeria is the same mass that you have outside the country. Are you with me? So the mass does not vary from place to place. I think that's that under mass and weight. So let's clean the board and go to that of time. Now time is just like, a measurement of the duration of a place or of an event. So if you are in an event now, okay, let's say you are in school. Yeah, so you are checking, you are trying to say, okay, yeah, you are in class, in physics class for over 37 minutes now. So you now be like, time is going, we are trying to measure it. So use your stopwatch. I use your stopwatch to even check. Okay, what's the time now? 7 minutes. Okay, what's the time now? 40 minutes. Okay, the next 20 minutes. Okay, what's the time now? Okay, this is 1 hour now. So the measurements of your duration of an event. So what's the first one? So time. Are you with me? And the unit of time, we know now, the standard unit is what? Seconds. You with me? Seconds. And then our instruments that we use to measure the time is, your stopwatch now. Your stopwatch, your ticker tape timer, your atomic clock, and many more. Your pendulum, a simple pendulum, and many more. So, but we now have the most accurate instrument in the whole world that we use to measure time. What's that instrument? You should know the instrument too. That's your atomic clock now. Atomic clock. The most accurate in the whole world to measure time. So that's that on that time. Time does not even have much stops. So let's now go into length. So length, this is where the real work is. Your length. How long, how long an object or a body is. So your length, let's check. Let's check. Alright. Length. Now we're going to we're looking at the number of instruments on that length. So your length now, your length. Alright. So your length here, we'll be looking at various instruments used to measure length here. Choose your meter rule. You know your meter rule now. Your meter rule, your vernier caliper, and then your micrometer screw gauge. Micrometer screw what? Gauge. Are you with me? So the three of them. Now, what will meter rule do? Meter rule will measure length. What will vernier caliper do? Vernier caliper too would measure length. What would micrometer screw gauge do also? Micrometer screw gauge would measure length. Are you with me? So now, let's now check. Three of them is actually measuring length. Length of what? Length of what and what? You know, this one now will measure the length of round objects, which is your vernier caliper, right? Then your micrometer screw gauge also would actually measure round objects also, round or cylindrical objects. We'll come back to that, but let's take it one step at a time. Under your meter rule, or first let's check for their reading accuracy and their smallest division first, because this is very important. That's what you will be needing under their calculations, because we have calculations under them. Now your meter rule, what will be the, let's look at their reading accuracy stroke their smallest division. Are you with me? So now the meter rule, what will be the reading accuracy of a meter rule? It's simply your 1/2 now. So your 1/2 is 0.5 abi. Let me first write that 1/2 down, because anywhere you see meter rule, just first of all write 1/2 down. Then after you write 1/2, you just know that wow, 1/2 under inside my calculator, if I should press 1/2, it will give me 0.5, right? You need to cram? No, just know your 1/2. When you know your 1/2, you know your meter rule. And they are measured in millimeter as well as centimeter. This one too, the same thing, millimeter as well as centimeter. This one too, millimeter as well as centimeter. So you can see the three of them now. But now the millimeter in meter rule, the millimeter will be to 1 dp, that's 1 decimal place. Then centimeter will just be 2 dp like that. Same thing for vernier caliper, 1 dp, 2 dp for centimeter. But under micrometer screw gauge, micrometer screw gauge did not gree for 1 dp, so him will start from 2 dp. Hey. So then centimeter, your cm, that will be 3 dp like that now. After 2 is now, so 2 dp. So that's that for that. So now let's now check for the value. The value. Now for meter rule, I told you that when you hear about meter rule, what should come to your head first is 1/2. And when you press 1/2 in your calculator, you derive at the first dp, the millimeter, this thing of a meter rule, which is what is 0.5 millimeter. So let's write it. Is 0.5 in millimeter. What will that be? The centimeter. It will be 0.05. You know your 2 dp now. 0.05. Your 2 dp 1 2 now in centimeter. So that's that for your meter what rule. Are you with me? Are you with me? Then vernier caliper. Vernier caliper is measured to 1 decimal place and 2 decimal place also. Yeah. How are we going to know that okay, this is what they will use? For example, when you are little, when you are very small, when you're in KG1, KG1, you're just learning things. The very first thing you would learn under numeration, in mathematics is show number 1. Even when if you like, the very first thing you never know in your life is 1. So we can call that one your fundamental quantity of life, because it's from that one other quantities actually came. It came from that one. Sure you get. So from 1 you begin to write your jargons 1 1 1. Then you are trying to do slash dash. So Other vernier caliper is this one that you use, meaning that you use one here. So your millimeter will not be 0.1 like that. So the one that we are using, you already know how you write it professionally now. So 0.1, 0.1 in millimeter, and I told you that your millimeter is in 1 dp, then your centimeter is in 2 dp. So that means your centimeter will just be 0.01. Simple. 0.01 in centimeter. So that's that. 1, 2 now, 2 dp now. So you get. Now going to micrometer screw gauge. You're actually using what we first learned in our life. That's number 1 now. So we know that 2 dp will now be 0.0112 now in millimeter for its millimeter. Then the 3 dp will now be 0.123 in centimeter. Shall you get the scope now? So that's the reading accuracy. Please take notes. Take notes. If you don't understand, you should review this thing again. Review it again. That's why it's a video. So now let's check for their smallest division, because smallest division is not the same thing as the reading accuracy. Are you with me? It's not the same thing as the reading accuracy. Let's now check for their smallest division. Their smallest division you start from. What's that number? I told you that 1 is the very first number you learn in your life. So the very first number when you were 1 year old, 2 years old, the very first thing you will learn in mathematics is number 1. So that number 1 is your smallest division under meter rule. Please take note too. So under meter rule, your smallest division is what? 1. Are you with me? 1 in millimeter. Then going to vernier caliper, it will now become E0.1. For vernier caliper is 0.1 in millimeters. Then under micrometer, you now have your 0.01. 0.01 what millimeter. So that's the smallest division, and these are what you'll be needing under calculation aspect of all these things. Sure you get. So reading accuracy of a meter rule to 1 dp, you should know that the very first thing I said you should take note of is that under meter rule, just picture 1/2, then in your head press it into your calculator. The 1/2 is 0.5 now, so that's your 0.5 millimeter for 1 decimal place. Okay, under meter rule, your millimeter is under 1. It's to 1 decimal place, and it's 0.5 millimeter. Then for the centimeter, it's just to 2 decimal place, which is 0.0. No, sorry, 0.5. 0.5. Sorry, 0.05. 0.05. Then vernier caliper, the very first number you learn when you were very little is number 1. So a vernier caliper 2, 1 decimal place is 0.1. Get for a millimeter. Then going to centimeter, it will now be 0.01. Same for micrometer screw gauge 2, but the millimeter is to 2 decimal place, while this centimeter is to 3 decimal place. So then for the smallest division under meter, that one will be just 1 millimeter. The smallest division of vernier caliper will now progress to 0.1 millimeter. Then that of micrometer screw gauge would be 0.001. No, sorry, 0.01 millimeter. So that's that under their reading accuracy and their smallest division. Let's now go into what they do. What do they do? What do these people do? What do these people do? So yeah, let's look at what they do. What do they do? So we have our micrometer. Sorry, our meter rule first. Our meter rule. We have our vernier caliper. Then we have our micrometer screw gauge. Micrometer screw gauge. So yeah, Now, meter rule is actually going. You are going to use meter rule to measure short distances. Like when you want to measure your book at home, quickly go and carry your meter rule or your ruler. So, of a book, a pen, a table, all those short distance that you can just easily measure. That's meter rule for you. And don't forget the graduation. Don't forget the reading accuracy now. So me now, I will not look at my book and I know it because I know that it's from my 1/2. And 1/2 is what 0.5. That's in millimeter. Then simply my centimeter will just be in two decimal places like that. So and you are done with meter rule. Are you with me? Then vernier caliper. So here, vernier caliper is actually going to measure diameter. It's actually going to measure thickness also and depth. Please don't forget. Now, this diameter is now into like something like the external diameter and internal diameter. So, diameter of what? Diameter of round objects or cylindrical objects. When you have round objects or cylindrical objects, you're actually going to go and use your vernier caliper. So now the diameter, it might be maybe diameter, the external diameter of a rod. You get external diameter of a rod, or let's say of a wire, or cylinder. Sure, you get or pipe. That's vernier caliper. That's what you use to measure it. So now, thickness of what? You would actually use the vernier caliper to measure the thickness of a what? Meter rule. Are you with me? The thickness of a meter rule. Why the depth? You can use vernier caliper to measure the depth of hollow objects. What do I mean by hollow? Something that has hole. Something like your bone cavity. You know that there's one hole in your bone. That's your cavity. So this vernier caliper can even measure itself. So far it's a cavity, so far it's a hole. So yeah, so your depth here would measure like depth of hollow objects like your bottle, your test tube, stuff like that. You understand? So that's vernier caliper for you. Let's now move to micrometer screw gauge. Micrometer screw gauge would also measure the diameter of round and what cylindrical objects, just like vernier caliper would do. And once I told you the reading accuracy now, that the reading accuracy of this one is to 2 dp and 3 dp. 2 dp is for the millimeter parts and 3 dp is for the centimeter parts. And I told you the very first thing we learned when we were small is 1. So that means this one will be 0.01 in millimeter and 0.0001, 1, 2, 3. So in centimeter. Sure you get now. So that's for micrometer screw gauge. Then what do we use micrometer screw gauge? What do we use it to measure? So I told you that round object too, just like vernier caliper, but here micrometer would actually measure something like your pendulum bob, something like your metal plate. That's what micrometer screw gauge would measure. Your metal plate, your thickness of a paper, thickness of to measure the thickness of a thin converging lens and all of that. Now, if it's now happened that they put these two instruments inside one option, they are now asking you to like choose one. So the very first thing you go and check in that question is the length of that object they are giving you. If it's actually having great length, like length is very big, you go for vernier caliper. Are you with me? Know that meter rule will actually measure length. Let's say short distance length, sure you get. But vernier caliper is actually going to measure smaller length. Are you with me? Why micrometer, from the word micro, it would measure very micro length, like very small, very small, very small. So if you have a ball that is like this and you have another ball that is like this, which one would you use to measure which one? For example, now this big one, now what will you use to measure this big one? What will you use to measure this big one? I'll actually use my vernier caliper now, because my vernier caliper is the one that can measure something that is kind of big, small, sharp. So but my micrometer screw gauge, from the word micro, it will be measuring something that is actually small, that is smaller than that is so. But Brainiac caliper will not measure it because it's too small for it to like measure. Are you with me? So micrometer screw gauge now, we'll use it to measure this one like this now. This one. So this object A would use a micrometer screw gauge, while object B would use a vernier caliper. Are both objects round? Yes. Are both instruments used to measure round objects? Yes. But depending on their size, depending on their length, that's when we now know okay which one we should use for which one. You get? So I think that's that under what they do. Under what they do. Then after that, let's go into error in measurements. Are you with me? Error in measurements. Somebody should clean the board for us. Error in measurements. So let's take calculations under this error. These are calculations that students always find it very, very difficult. Error in measurements, right? Okay. So now what is error in measurements? It's very simple now. From this, get our definition from m plus or minus e. So that means that our measurement, our error in measurements is the difference between our measured value and our exact value. Let's call it our actual value. Are you with me? So the difference between both of them, either m minus e, m plus e. Are you with me? So the difference between your measured value and your exact value or actual value is giving us error in measurements. Now we now have what is called percentage error. Percentage error is now your absolute error over actual value times 100. And what is your absolute error? This is your absolute error. Your error in measurement is your absolute error, meaning that your percentage error will now be equals to your absolute error. What's your absolute error? M minus e. You write it. Your measured minus exact value. Are you with me? So divided by your actual value, which will be given in the question, and your 100. Are you with me? Now, depending on the kind of instrument, because you have to check in that question, they will give you like maybe they will say the meter rule is marked in millimeter. That means you are expected to use the reading accuracy of of a meter rule that is marked in millimeter. That's 0.5 millimeter. So there are things to do. Let's take one example so you can understand this thing very well. Let's take one example. Yeah. Let's clean the board first. Let's take this let's take this question. Alright. It says what is the percentage reading error? Alright. So they're asking of your percentage error. Alright. Your percentage error. That's percentage error. That's what they are looking for. Alright. Then they said in measuring a distance of 5.00 centimeter, that's your actual value. So your actual value was given in the question. Actual what value as 5.00 what centimeter. So it's in centimeter. Please take notes. Centimeter. Then now, how did they say you should look for that percentage error? Right? They say that using a meter rule marked in millimeter. So the millimeter rule is marked. You can see what they said though. So they are using meter rule, and the meter rule is marked in millimeter. Are you with me? So since the meter rule is actually marked in millimeter, what is the smallest division? Because for you to the formula you use, let's check our formula first. This is the formula: percentage error, which is equals to our what? Our absolute error over actual value multiplied by 100. Are you with me? Now, what is your absolute error? That's what we have to look for now. Absolute error would be half your smallest division. Half your what? Smallest division here in this question. What's your half smallest division? Now, which instrument are we using so we can know the smallest division of that instrument? So we are using our meter rule now, as stated in that question, meter rule. So since we are using our meter rule, then we can know that our meter rule smallest division is what? I told you that the very first thing we learn in our life, we never learn when we were 1 years old, when we were on meter rule now, because meter rule is what you want to use now. So you have to know the smallest division, and I told you what the smallest division is. Like the very first number you learned in your life when you were very small, when you were in KG1, all right, KG1, or even when you were 1 year old in mathematics, your mommy will first be teaching you one, write one, write one, write one, and that's your fundamental mathematics, from which order derived mathematics came from. You get? So that means my smallest division is just 1 millimeter. 1 millimeter. So meaning that my absolute error here, which is half smallest division, would be what? 1/2 multiplied by 1 millimeter. Are you with me? So 1/2 multiplied by 1 millimeter. Press your calculator, let's get our absolute error. So that's 0.5 millimeter, right? 0.5 in millimeter. That's good. So let's now go back to our formula, which is absolute error over actual value multiplied by 100. So now your absolute error is in millimeter, right? 0.5 millimeter divided by actual value. Actual value is what? 5.00 centimeter multiplied by 100, but C is not correct. Since they give you your actual value, your actual value in centimeter, you have to convert this value you got for your absolute error from your instrument. You have to convert back to the same unit your actual value is having. And how will you do that? Just if you are converting from millimeter to what? To centimeter, what will you do? That would be your 0.5, then multiply by 10. So when you multiply it by 10, you've converted like that. So just multiply by 10, then I think you are good. Then that will be 0.5 multiplied by 10. So yeah, press your calculator. Let's see what 0.5 multiplied by 10 is. 0.5 multiplied by 10, that will be 0.05 centimeter. 0.05 in 1 centimeter. So you now go back here. So here you put 0.05 in what? Centimeter. So can you see that you have been centimeter like that, up and down? So now what would be, just press your calculator, this one divided by this one, then multiply by 100, if you are take it to 1 meter. So that's your answer. 1 meter. Not meter self, you're looking for percentage error now. So your distance should be in percent, not meter. Percent. So percent. That's it. Alright, let's now check another question again. Question says that. So this says let's just do an external diameter of the road as 100 plus or minus 1 100 plus or minus 1 millimeter, right? Then now says that, and 104 plus or minus 104 plus or minus 1 in millimeter, right? In millimeter. Are you with me? So next I should find the percentage error in the thickness of the tube. Now what do? What you will do is that So that way, this is how you write your parameters out. Then you simply do like this now. Okay, my 100 minus 104, alright, that's just 4. You don't need to do any wahala here. Then you don't have any problem here. So 1 minus 1, you cannot say 1 minus 1 because 1 minus 1 will be 0 now. So definitely you have to add this side. 1 plus 1 is now 2. So now 2 will come up 2 over what? 4 multiplied by 100, and that's the answer. Are you with me? Check again, check again, check again. From 100 plus or minus 1, 104 plus or minus 1. Now this side, you are subtracting 104 from this, giving you 4, alright? Then 1 and 1 is here. You cannot subtract. It will give you 0, and you will not see anything to calculate. So just add that place. 1 plus 1, and 1 plus 1 becomes 2 will be up. That will be your, that will be what you place off. Then the one that will be down will be 4. And 2 over 4 multiplied by 100. So multiply your answer. Let's see. What will be your answer? That will be 1 over 2 times 100, then 50% like that, sharp. 50%. So then, and that's that. Very, very easy. So you should do for, if, let's you do for, if I change this one to 109, and I change this one to 103, and then maybe this one is, yeah, like that. So you should be able to do this one by yourself. And let's call it a beautiful session. It's a surgical medic, and it is a routine for you always.